I'm going to talk about one function in PHP for 20 minutes. It's just about extract. So you might wonder why that function. And if you look at the documentation on php.net, there are descriptions of what every function does. And sometimes there are additional warnings about what you shouldn't do with the function. And if you look at this warning, it says, yeah, you shouldn't use it on untrusted data, like coming from a user over a GET request. And I was wondering, we were wondering why and what could go wrong, and do people actually read the documentation, or are they just implementing stuff on their own? And that sparked this journey. And first, I need to introduce the function itself, what it does and how it works. And then we have to look at some PHP code. So this is a normal array in PHP, and you can access it using these parentheses. And you access the key 1, and then this one would output the value of this key, which is value 1. And now if you use extract on this array, it extracts all the keys and puts it into local variables with the values in the array. So now we have a magic variable that we never declared beforehand, and we can just access the key in the array as a variable, and it would print the same thing. And you might wonder, why would we need this, and what would happen if there is already a variable key 1, and what would the value be now after we call extract? And extract has this flags argument where you can decide what should happen if the variable is already existing. And we can go through this. We have the variable key 1 defined beforehand, and then we call extract and have the same key. So we have a collision there. And the keys are by default overwritten. So if the variable already exists, you just replace the value, and the output will be the one in the array. But you can decide to skip any already existing variable and just add new ones. So now we still have the old value in key 1, but key 2 is added to. And you go the other way around. You only change values that are already defined. So you can say, I only want to change key 1, and key 2 is now undefined, not even there, because we never declared it beforehand. And there are a few other options. You see this third argument with prefix, and they are more secure because every key is prepended with the prefix shown here. So this is not really something that we go on to talk about here. But still, I haven't really shown you anything what could go wrong now. So this is like a little CTF problem, as I said in the introduction. I'm really deep into that. And this is like a small application using extract. And it's supposed to be hard to guess the correct number because you're not given the number. And you send a request and guess the number. And it's going to be compared to some other value, and it's probably wrong. But you can just send your own secret, and then the comparison will succeed. So you can change any variable, even if the intended or the developer didn't intend you to change it. And now we have to look at how we can actually put values into PHP applications. We look in at web applications, so they are hosted using Apache or Nginx, and usually use PHP together with HTTP. So you can post or do GET requests and access those values in the parameters using these super global variables, and they are just available in your script, and you can use it. And the first ones are for the actual values that you can control in the parameters, and they are the keys and the values are controllable by you. And the request one at the end is, by the way, only a merge of the first 3 ones. So get, post, and cookies are all available in the requests. But then there's the files one. If you upload files, there's a predefined value for this key. So you can only define the name of the variable that you might overwrite or change, but the value is a predefined structure. But this is not all. PHP has a rich support for parsing complex forms, so you can actually create arrays using this syntax where you append the query parameters using these parentheses, and then it would create an array with 1 and 2 as the values, and you can go a step further and create maps or associative arrays where you specify the key and then the value in the array, and then you would get an actual array prefix, the value, key of prefix and the value of WOOT. And this gives a potential attacker a huge advantage or possibility to actually change values in more interesting ways than just the strings. So now with this at hand, we wanted to know if there are any real-world applications using this, but we didn't want to look at them all at our manually and on our own. So we created a static analysis pass for a existing code property graph for PHP. So this little application on the left is represented by this little graph on the right. And you can imagine it blows up really fast. You're not supposed to actually read this. It's just for scale. And the analysis now looks through this graph of code property graph. It's a combination of different representations of the source code, like the abstract syntax tree and the data flow analysis, and they are all combined into one big graph, and you can walk around it over all these different combination of information extracted from the code. And first, we look at calls to extract in the code, if there are any. And then starting from this call, we go up and prune all paths in the code that don't reach this one. So we only have a subset of this graph that actually could reach the extract call. And then we see if any flow exists to these get or post superglobals. So the user input is used in conjunction or reaches the extract call in some way. This is really broad and might catch other usages in the extract call, but this is good enough to actually do a large-scale analysis. And that's what we did. We used a data set from around 28,000 PHP repos on GitHub. And we analyzed them, and we found that 1,300 of them used extract in some way. And in a total, they had around 5,000 calls to extract. But they are just calls. They might be not involving user input. So only 33 repositories were with user input, and there were 146 extract calls. So this is manageable in the manual analysis, and that's what we did now. We looked at all these extract calls and found that in 26 applications, there were actually over 100 exploitable calls. And we will go into more detail in what exploitable means in this actual context and not in this CTF task that we saw before. And additionally, we looked at how the flags were used that we talked about earlier. And this graph shows the blue bars where it's all the extract calls, the 1,300, around 5,000 extract calls. And the orange bars are just the 164 extract calls involving user input. So you see most people don't use the flags at all. So the default is just not passing any flags, which defaults to the override flag, which means we just replace any variable that is in the array that we extract and override the values. But we can see that if the user input is used, the developers were more aware of the flags and used them in a higher proportion to just using hard-coded values. So there might be someone who's actually thinking about security when using extract. Now I want to go through some of the examples that we found in the dataset. And we'll see some PHP code here, and I will go through it line by line. This is from a control panel which you can use to administrate some users and telephone numbers. And you can see the pattern here. The developer tried to be secure. They used prepared statements, which are a good pattern to use to prevent SQL injection in web application or in any application. And they actually thought about security and tried to prevent any problems. But now if we look at the top here, we have the extract call to just post. So we can post any value and we can override any variable in the application. So if we look at the first line above the extract call, there's a variable defined there called table, which is just concatenated in the query below. So the developer clearly didn't intend anybody to change this variable, but just other variables. But there's no technical limitation doing actually enforcing this. So to exploit this bug, we can just add another variable to the query, to the post message, and change the table variable to anything. So we can delete all users with this query without the application actually working with the users at all. And you might see that there are accesses to the post array on its own, where it checks the address source and the extract call above, which might lead to the conclusion that there are multiple developers working on this application, and somebody used extract once in the past, and they just didn't touch this code and added their own. So this is lingering in the background, and people might not really be aware that there's a problem in their code. And this is where the name of this talk came from, the foot gun in PHP, because this is just a foot gun waiting to happen. It's still there in the code. I mean, now it's patched, but it was still there in the code. And people worked around it and didn't even use the feature of extract in all the code following it. It was just a relic from the past, I guess. But this is not the only thing. There's this table variable, that was defined by the user manually, but you can look a step back and look at other variables that are usually available in PHP applications. You can, we saw the get variable and the post one, but there are others like the _server variable, where the server puts data into, and you can't really influence it. And in this scenario here, you can see that you have to send a HTTP GET request, and we want to reach this header location redirect path. But it checks for a post request, because the post field is only set when a post request was received by PHP. What we could do now is send a request like this, where we set the post variable through a GET request, and then change the request URI, which is usually hard-coded by the server launching the PHP application, to something that we control. So with this request, we change data that isn't supposed to be changeable in this scenario, and allows the attacker to reach code that isn't supposed to be executed in this request. So this allows you to do an arbitrary redirect and send somebody a phishing mail with a benign-looking link, correct URL, correct domain at the start, and then you can change the way, the redirection, and move them to your own shady store that looks just like the original one, but isn't. And you can see this global variables thing being a problem. And we can go even one step further. In another application, there are other variables used. You can look at the environment of the server and change it, or more interestingly, the session. And the session is a mechanism in PHP which is using a cookie to store some random value, which re-identifies the user if they come back. And then it repopulates this session array with the data that was put there in the previous request. So if we look at this code example, we see the session is started and some default values are put into this session. And then later, extract is called with our user input, and again, with default values for random variables if we don't add them ourselves. But if we look below, the session is checked for if we are an admin or not. So now we can add a request at the bottom where we just change the session and replace the whole session object with an array containing admin equals 1. So this check would pass, and we achieved privilege escalation in our exploit. And now we can reach the paths below and, again, delete users. And this is cool and all, but this can go a step further if we think about the persisting of sessions over multiple requests. Because now this value would be saved to the session store, and the next request to this application with this session cookie would retrieve the same session array, and we would be still admin on some other page. So we can think about this like unlocking the application, not just for the code path this immediately follows, but on other sections of the application too. And the application doesn't have to have the delete user query right after you call extract, but you can call you do one request to one application endpoint which has the extract vulnerability, change your admin status, and then go to some other page and use your admin rights now. So this is pretty serious. And if we look at the overall picture, it was pretty common too. These are the numbers of vulnerabilities that we found in total, starting from every extract call. And every extract call can have multiple vulnerabilities. Usually, there is some variable that you can change that would be reflected to the user. So the XSS part is really common. But on the other hand, down below, the privilege escalation, if the application uses sessions, you would usually be able to change the session. There's one keyword here. The reason why it's lower, that the global variables are only really replaced in all contexts if extract is called in the global context too, and not inside a function. So if extract is called in a function, you can't replace the session everywhere, but just for the local scope. And the privilege escalation wouldn't be global. We thought first, well, this function is so old, nobody uses this anymore, right? But if you look at this graph, there are the year of the last commit in the different repositories on GitHub where we found this stuff, and they are active today. And the most prevalent one was OpenZips, a voice over IP implementation, and their web interface had a bug. Actually, the first example thingy that I showed with the table, they had a privilege escalation 1.2, but I want to show a different example. And their bug fix was to just remove all usage of extract. And that sounds like a good idea. If we come to the mitigations, how to prevent all this, the easiest way would be to deprecate and remove extract, but I mean, there are many more usage cases where you don't use the user input into the extract calls. And on top of that, PHP is really concerned with backwards compatibility, so you can't just remove functions, even if they are a common footgun for developers. So we thought about different not that intrusive ways to prevent this. And the easiest one would be to prevent overwriting global variables. That was the most prevalent one to actually get a more persistent problem exploit. And interestingly, the globals variable, which is just available everywhere and you can put stuff in there, that is already filtered, so you can't replace that one. But all the other global variables, like server, session, get, post, is not. So that looks like an oversight, and maybe the same reasoning can be used to replace or add the other global variables, super global variables, to this filter too. We proposed this to the developers, and they weren't declining it right away, so maybe it goes their way, but it's not into any form where they actually changed the language yet. And another one is that the actual mitigations in the root cause of this problem is that we can overwrite any key, even the ones that the developer didn't intend. So if we add another parameter to extract where you list which values you actually expect to be written, then you prevent this problem where you can write any other variable that you didn't think about. So to sum up this talk, the initial question, if people read the documentation, is, well, maybe. I mean, they mostly don't use extract with user input, but if they use it, they probably don't read the documentation, because there were lots of calls that weren't protected. And as we've seen, the extract call and the extract function is pretty easy to misuse, because you have to think about which other variables might be overwritten by this call that you didn't intend to. And the most important message from this one is that the super globals are really easy to exploit, and they should be protected in a more intensive fashion to actually protect users from not reading the documentation and still be safe. And with this, I'm done and happy to have any questions.